Hello, welcome to Marsh Mathematics, and in this video I'll be going to be looking at solving trig equations for year 1. Now I'm going to solve a nice easy trig equation here, but I'm going to use both methods. So in all examination boards now they teach both methods, and depending on what teacher you've got, they will some of them will teach one method or the other, but I firmly believe that you should know both methods and then choose the best method that suits you. But it is useful to be able to do both methods. Okay, now we've got sine theta equals root 3 over 2, and this is the range. Okay, this is the range of values for which we need to solve this equation. Okay, now the first thing we do, I'm going to use the graph method. Okay, now what you would do is you type in your calculator, theta equals sine to the minus 1 of root 3 over 2, and you're going to get 60 degrees. Now this is called the principal value. It's the value your calculator is going to give you. But you should know that there's an infinite amount of values for sine theta equals root 3 over 2. Okay, so all of these questions really involved finding a set of values that fits into the range that they give you. Okay, so you really must focus on the range just as much as the equation. Now there's a graph here, so you'd have to draw a sketch of a graph, and the red part of that graph, this bit here, shows you the range of values that your calculator will give you. Okay, it's programmed to give you a value for sine, cos and tan within a specific range, and that range for sine is minus 90 degrees to 90 degrees. Okay, but we know there's an infinite amount of values. Now they've given us a different range to this one. Okay, so what we've got to do is find out what the other values are. So the first value we can see is in green here, and that's the principal value, which is 60 degrees. So I've shown in red where the other values are within this range, because this is a graph of between minus 360 and 360. So what we do is we use the symmetry of the graph to work out the other values. Okay, so if this is 60 degrees, this value here must be 60 degrees. Okay, so the next value this is 180 here, so for this one it's just 180 minus 60, so that's 120 degrees. So we've got this value and this value so far. Now so that's between 0 and 360. Okay, there's no more but if going in this direction to 360, but we have to go, the range says we've got to go back to minus 360. So if we go backwards, we can see we've got two more values here that are the same height. They give you root 3 over 2. Okay, so because of we just look at these two sections of the graph, and we can see that this must be 60 degrees and this must be 60 degrees. Therefore this is 30 and this is 30. Okay, so the next value will be minus 180 minus another 60, which gives us minus 240. Okay, which is this one. And then the next one is going to be minus 270 minus another 30, which gives us minus 300. So that's the graphical method. So the only thing about the graph method is that you've got to draw a decent graph or sketch a graph. Okay, and then you've got to start working out all the different values. Now some people would prefer that method. I personally think that you should be able to use both methods, but in this case I think the CAST method is equally as good. Sometimes the CAST method is better than the graph method. Most of the time it is. Okay, now I'm going to run through I'm going to do another video explaining why we can use the CAST method, because the CAST diagram relates to the graph. They really mean the same thing. Okay, so for now though, I'm just going to talk about the method of using it. So we've got exactly the same question. Okay, we've got exactly the same question. Solve this equation. Okay, within that range. Now this is what you do. You draw a CAST diagram. Okay, so a CAST diagram is this here. This is the cast diagram. Right, so the letter CAST tells you what where sine, cos and tan are positive. So they're all positive in this first quadrant. Sine is positive in the second quadrant. Tan is positive in the third quadrant, and cosine is positive in the fourth quadrant. So what we do when we got a question like this, what we do, we find this angle alpha. Alpha is not the same as theta, and it's not always the same as the principal value, so just remember that. Alpha is the angle that we make, that this angle, these solutions that we're going to find, make with the x-axis. This is the x-axis and this is the y-axis. Okay, so all we do is we put alpha equals sine to the minus 1 of root 3 over 2. We get 60 degrees. Now this is the same as the principal value, but if we had an equation that said sine theta equals minus root 3 over 2, we'd still say that alpha is sine to the minus 1 of root 3 over 2, because alpha has got to be between 0 and 90. Okay, so it's not the same as the principal value. It is in this case, but it isn't in other cases. So we draw that diagram. So if we were finding alpha for this, we just ignore the minus sign. It's an angle between 0 and 90, and from this diagram we are going to find the solutions. So what we do, we use the cast diagram. We say, right, well, sine theta is equal to root 3 over 2. So sine is positive. So sine is positive. So the angles must be in this quadrant, the first quadrant, because all of them are positive in that quadrant, or the second quadrant, because sine is positive in the second quadrant, but negative in the third and fourth. So we go round and we go round in an anti-clockwise direction and a clockwise. That's the plus direction and that's the minus direction. So the first angle we're going to come across is this angle, and we know that's 60 degrees because alpha is 60 degrees. Then the next angle we're going to come across is this angle. Now, are we okay to use this angle? Yes, because sine is positive in that quadrant. So this angle here is 180 minus 60, because alpha, remember, is 60 degrees. So that gives us our 120. But if we keep going round in this direction, we can't use this alpha and this in the third and fourth quadrant, because sine is negative there. So it's only those two values. So then we look at the direction between minus 360 and 0, or 0 going back to minus 360, and we go back in this direction. We can't use this one, we can't use this one, but we can use this angle here, because sine, we're in the second quadrant and sine is positive there. So this is going to be minus 180 minus another 60. That's what's going to give us this angle here is minus 180 minus another 60, which gives us minus 240. And the final one, sorry for all the scribbles, but this is what you have to do, is we go all the way around here now and all the way back to there, because we're going negative now. We're going in the range of 0 to minus 360. We go all the way around to this alpha. We can use this one because this is in the first quadrant and sine is positive in the first quadrant. So that is minus 270 minus another 30. Okay, this is going to be minus 270, because remember this is 270 here. Okay, minus another 30, which is minus 300. Or you can just say 360 take away 60 to give us minus 300. So there are the solutions. So we found both sets of solutions using the cast method, and we got the same solutions using the graph method. We have the same set of solutions. Now it's up to you to decide which is the best method. Some people find the cast method a little bit confusing. you're the judge of that. Okay, I actually prefer the CAS method because it's quicker when we get the harder questions. In the next video I'll be looking at a couple of harder questions, and I'm going to use one method. I'm going to use the graph method, then I'm going to use the CAS method, and so you can see how both methods are used.